Hello everyone. So here in this part 4 of this chapter on current electricity, we shall start solving from the question number 67 onwards. In the previous three parts, we had solved till the question number 66. So if you have any doubts, then please write us in the comments section, or in any other chapter. If you feel more difficulty, then write the name of that chapter also in the comment section. And some important homework questions will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. Question number 67, it is told that a metal rod of length 10 centimeter. There is a metal rod which is having length 10 centimeter and a rectangular cross section is having a rectangular cross section that is 1 centimeter by 1 by 2 centimeter, is connected to a battery. It is connected to a battery across opposite faces. The resistance will be how much? So the resistance will be maximum when the battery is connected across 10 centimeter across one faces. Okay. So the metal rod is somewhat like this. It is in the shape of a cuboid. So know that R equals to rho L by A. So the resistance will be maximum when the length is highest and A is minimum. A should be minimum. So this face is 10 centimeter by 1 centimeter, you can tell. This front face is 10 centimeter by half centimeter. This face is 1 centimeter by half centimeter. So it means that it would be maximum when the battery is connected across 1 centimeter by 1 by 2 centimeter faces. It means that option C is the correct answer. Then question number 68 is told a car has a fresh source battery of EMF 12 volt. Fresh source battery, a battery is there of EMF 12 volt, an internal resistance that is 2 into 10 power minus 2 ohm. If the starter motor draws a current, starter motor draws a current of 80 amperes, then the terminal voltage when the starter is on, then the terminal voltage V will be E minus IR, that is 12 volt minus 80 ampere into 2 into 10 power minus 2. This is 2 by 100. 12 minus 0.8 into 2. 2 8 is a 1.6. 2 8 is 16. So 12 minus 1.6, that is 10.4. Option A is the correct answer. Then in question number 69, it is told each resistance in the given cubical network has resistance 1 ohm. Has resistance 1 ohm, and equivalent resistance between A and B is how much? So here we can say that if suppose from here through this I current each resistance of 1 ohm, and from here I current is flowing, then this, so this is symmetric. So here also I by 3 means suppose 3 I current is flowing, then I current will flow through this, I current will flow through this resistance, I current will flow through this resistance. And here also like I and I will come here in. So from here I by 2 current will flow. Here also again I by 2 current will flow. From here also again I by 2 current will flow. This also I by 2 current will flow. This also I by 2 and this also I by 2. I by 2 plus I by 2, this will be I by 2 plus I by 2, this also will be I by 2 plus I by 2, this. So then if we apply the Kirchhoff's voltage law, the R equivalent here, therefore the R equivalent, that will be equal to VA minus VB divided by 3I. So if we apply the Kirchhoff's voltage law, this will be VA, I can write, this will be minus IR minus IR. R is 1 ohm. Each resistance is 1 ohm. So VA minus I by 2 minus I, that is equal to VB. So therefore VA minus VB, that is equal to 2I plus I by 2. That is equal to 2 to the 4, 5 by 5I by 2. So VA minus VB by 3I. That will be equal to 5I by 2 divided by 3I. This will be 5I by 6I. This is 5 by 6. 5 by 6 ohm. Option C is the correct answer. Then question number 70 is told, a potentiometer has a uniform wear of length 5 meter. It has a uniform wear of length 5 meter. A battery is there. A battery EMF 10 volt and of negligible internal resistance. The internal resistance is 0. It's connected between its ends. A secondary cell connected to the circuit. Secondary cell is there. So that gives the balancing length of 200 centimeter. The EMF of the secondary cell is. So it means that here voltage drop, the voltage drop per unit length, that is phi, voltage drop per unit length in the potentiometer wear, voltage drop per unit length, the potentiometer wear, the potentiometer wear. So now this is the potentiometer wear, which is having 5 meter length, which is having 5 meter length, so that is 500 centimeter length. So, voltage drop per unit length in the potentiometer wear, that is equal to, this is 10 volt divided by 500 centimeter, that is equal to 1 by 50 volt per centimeter. So this is phi. Now therefore the external EMF of the cell, the EMF of the secondary cell, that will be equal to phi into L, is the balancing length. So phi is 1 by 50 volt per centimeter into the length, the balancing length is 200 centimeter. 5 4s are 20, so 4 volts. So option C is the correct answer. Then in question number 71, it is told the color code of a carbon resistor of resistance 0.28 kilo ohm plus or minus 10 percentage. The color code for a carbon resistor of resistance this is 0.28 kilo ohm, so I can write it as 280. I can write it as 28 into 10 power 1 plus or minus 10%. So 28, so we know that the color code of resistor is BBROY GB VGW. So this is black, brown, red, orange, yellow, green, blue, violet, gray, white, then silver, white, then gold, silver, then color. So for black, the resistance value you can write, and the tolerance, which is the delta R by R in percentage, which is the percentage error in the resistance. So black, it is 0, 1, for red it is 2, orange is 3, yellow is 4, green is 5, blue is 6, violet is 7, gray is 8, white is 9, gold, the tolerance is 5%, for silver the tolerance is 10%, for color the tolerance is 3%. So therefore this 28 into 10 power 1, so 28 means it should be, first should be red, and 8 is gray, so it should be gray, red, gray, and then into 10 power 1, so 1 is there, so it should be brown, and then 10% means it is silver. So this should be the color code of the carbon resistor: red, gray, brown, and silver. So option C is the correct answer. Then in question number 72, it is IV characteristic of a copper wire of length L. There is a copper wire length L. An area of cross section A is shown in the figure. The slope of the curve becomes less if the area is increased. Okay, so IV. So in the IV characteristics, the slope is 1 by R. Slope is 1 by R. We know that R equals to rho L by A. So 1 by R will be equal to A by rho L. So the slope is A by rho L. It means that if the area is increased, then the slope also increases. Area is increased, then R decreases. The slope increases. And if the length is increased, then the slope decreases. Slope, if the experiment is performed at higher temperature. So if the temperature is increased, then the resistance decreases. So the slope increases. The slope of the curve becomes more if a wire of steel of same dimension is. Okay. So the slope of the curve becomes less if the length wire is increased. Means that option B is the correct answer. So here we shall end this part 4 on the current electricity. Hope you all have understood the every steps of the solutions of these 72 questions. If any other doubts if you have, then please write us in the comments section, and please install our Sapience education application. The link has been provided in the description, where we shall upload some very important homework questions on every chapter on KCET exam. So it shall be helpful for your KCET exam. So thank you everyone. Bye.